This is page 91 of your math journal. We're going to call this one Write and Graph Inequalities. Okay, when you're writing inequalities, do you remember that word chart we made on page 90? You're going to want to be referring to that. But inequalities represent real life situations. So we're going to we're going to look for clue words in what we're trying to talk about. I want you to always find the boundary number. So when writing inequalities, we want, I call it the boundary number. It's the number where the limit starts or ends. Alright, so when we're writing inequalities, let's do this for an example. You must be 36 inches or taller to ride this roller coaster. So looking at this, I want you to look at what your boundary number is. In this case, it's 36. So what are we saying compared to 36? What needs to be? You need to be 36 inches or taller to ride the roller coaster. We're talking about height here, so I want you to define a variable just like you did on equations. So I'm going to say h is height. So I'm comparing height to 36. Now here I just need to decide, how does it compare to 36? My height needs to be 36 inches or taller. So because it's 36 inches or more, it can be 36 inches. So first thing I want you to do is decide, can it be equal? In this case, it can. Now, how does the height have to be compared to 36 or taller? That means that h needs to be bigger than 36. Okay, let's try another one. A train travels in excess of 90 miles per hour. Okay, what is my variable here? What am I comparing it to? I'm going to say S for speed. Okay, my boundary number is 90. So I'm comparing the speed of the train to 90. Now this is where I gotta look at my wording carefully. A train travels in excess. This means above and beyond. So does excess mean it can be equal to 90? No, so it can't be equal. So then I have to decide, how does it compare to 90? Is the speed bigger than 90 or less than 90? In excess means more than. So I'm going to say that S is more than 90. Okay, let's try another one. the temperature of the freezer can be no more than 30 degrees Fahrenheit. Okay. So if we have this statement, 30 is my boundary number, and I need something to compare to that. So what are we talking about? We're talking about the temperature. So I'm just going to define my variable. I'm going to say T is temperature. So how does the temperature of the freezer compare to 30? First of all, I decide, can it be equal? So it says can be no more than 30. Is 30 more than 30? No. So it could be equal because it says no more. It can be 30, but anything over that, it can't be. Now, how does that compare here? Temperature, no more than 30. That means that 30 is as high as it could possibly get. Okay, you just have to read carefully into the words and think about it, what it's talking about and how it compares to that number that you're given. Okay, now we're going to talk about graphing inequalities. There are two things you need to know about graphing inequalities. So first, let's put graphing inequalities here. I'll give it a little bit of a title. Okay, first, find the boundary number. Second, decide if you need a filled dot. So open dot or a filled dot. How do you know if you need an open dot or a filled dot? Open means not included. So that would be this sign or this sign. How do you know if you need a filled dot? It means this number is included. So it's any of them with the little equal sign underneath it. Okay, and then step 3. Shade area where variable belongs. Alright, we're going to graph a few down here. Oh, up here on find the boundary number, I want you to write on a number line. I'm sorry about that. On a number line. Okay, so we're going to do 4 examples here. We're going to do V is less than 28. We're going to do -3 is less than or equal to F. Leave 1, 2, 3, 4 spaces. So I want you to write right here. 4 spaces. Okay. We're going to do M is less than or equal to 7 and Q is less than -4. Alright, so first of all, you need to have a number line. Now, as long as you have your number line and it's numbered correctly, you just need to be able to find that number on it. So in this case, I'm going to find 28 on my number line. And then I'm going to number some of them nearby it. So what's just bigger than 28? Well, 29, 30. All I'm doing is I'm showing a little snippet of the number line. 27, 26, 25, and remember that it keeps going. Okay, there's my snippet. My boundary number is 28. Now, open dot or closed dot on 28, because there's no equals here, this would be an open dot. So open dot on 28, meaning 28 is not included. But it says V is greater than 28. So which direction of 28 is greater than 28? It'd be this side. I'm going to shade it and make an arrow, because everything that direction is bigger than 28. And that's why you have to graph it. It's not just like an equation where you get it is this, and that's the only number it could be. No, it can be 29, it can be 30, it can be 29 and a half. It's any number bigger than 28. Alright, right here we have -3. So we're going to find -3 on the number line. I'm going to put -3 right there. Well, what's nearby it? -2, -1, 0, -4. As long as I know where we're at on the number line, it's fine. Know that the number line continues. This is just a little picture of it. Now, because this could be equal to F, I'm going to put a filled dot on -3. -3 is included here. Now, here's where you got to pay attention. Look at the way the mouth is facing. F is bigger than -3. So, even though the F is on this side, that part doesn't matter. I'm saying that F is bigger, so I need to go in the direction that is bigger than -3. So I'm going to shade in an arrow going that direction. Everything -3 and bigger works. Okay, I changed my mind on this one. We're going to make this, scribble out the 7, I'm sorry. I know I do that sometimes. We're going to make this 1/2. Because I want to show you it can work on fractions, decimals, anything you have. So let's make a number line. I need to find 1/2 on here, so I need numbers that are close to 1/2. So I'm going to pick 1/2 right here. If that's 1/2, I'm going to make this 0, and I'm going to make this 1. This would be 1.5. This would be -1/2. As long as I know where we're at on the number line, that's what matters. I'm going to put a closed dot on 1/2 because it is included, because it's equal to. Now, it's saying that M is less than 1/2. So I need to show everything that's less than 1/2. Everything that's less than 1/2 is in this direction. So I shade an arrow in that direction. Okay, last one. Let's draw a number line. I need -4. That's my boundary number. What's near it? Well, -3, -2, -1, -5, -6. It keeps going. Remember, this is just a snippet of the number line. Okay, it's going to be an open dot. It's not equal, so it's not included. Now, how does it compare to Q? -4 is bigger than Q. Q is less than -4, so I need to go less and shade an arrow in that direction. Everything less than -4 works. Okay, that's all you need to know about writing and graphing inequalities.